The objective of this lesson is to decompose rectilinear prisms to calculate volume. In previous lessons, students explored the formula for calculating volume. In this lesson, we will apply the volume formula as we decompose rectilinear shapes into multiple rectangular prisms. Let's begin by reviewing the formula to calculate volume. Here we have a rectangular prism. Its length is 21 inches, its width is 10 inches, and its height is 4 inches. The formula for volume is length multiplied by width multiplied by height. Using the commutative property of multiplication, we can multiply the dimensions of the prism in any order and arrive at the correct volume, 840 cubic inches. We cannot apply the formula for volume directly on irregular rectilinear prisms such as this one. We must first decompose it into regular rectangular prisms. This can be done in a variety of ways. The first method decomposes the shape into two rectangular prisms. We could use the formula to calculate the volume of each section and then add the volume measurements to find the total volume. The second method decomposes the shape into two long prisms. Again, we could use the formula to calculate the volume of each section and add the measurements to find the total volume. The final method decomposes the shape into identical layers. We could use the alternate formula, base multiplied by height, to find the total volume. As we begin decomposing it into smaller rectangular prisms, we need to know a few measurements that are not directly given. For example, this blue edge does not have a measurement. We can determine its length by looking at the opposite side of the prism, which has a measurement of 2 centimeters. Since the blue side and the 2 centimeter side are opposite sides of a rectangle, they are congruent. This means the blue edge is also 2 centimeters. Next, we need to determine the length of the red edge. We can decompose the shape along the dotted red line. Since we know the length of the long edge of the larger rectangular prism is 4 centimeters, we can conclude that the length of the blue line combined with the length of the dotted red line is also 4 centimeters. Since the blue line measures 2 centimeters, the dotted line must be equal to 4 centimeters minus 2 centimeters, or 2 centimeters. Since the dotted line and the red edge of the prism are opposite sides of our smaller rectangular prism, they are congruent. Therefore, the red side measures 2 centimeters. The image to the left shows what happens when the prism is decomposed. We can use the formula for volume to calculate the volume of each of the smaller rectangular prisms. The longer prism measures 4 centimeters in length, 1 centimeter in width, and 3 centimeters in height. Its volume in cubic centimeters is 4 multiplied by 1 multiplied by 3, or 12 cubic centimeters. The smaller prism measures 2 centimeters in length, 1 centimeter in width, and 3 centimeters in height. Its volume is 2 multiplied by 1 multiplied by 3, or 6 cubic centimeters. We can now total the products to calculate the volume of the rectilinear prism as 18 cubic centimeters. The next prism is similar in shape to the previous prism, but varies in measurement. As we decompose the shape, we need to discover several measurements not provided for us. To help clarify, we will color code each dimension using a different color. Lengths will be red, widths will be blue, and heights will be green. Since the height is uniform for the entire prism, we know each green edge measures 11 centimeters. We are decomposing this shape into a large prism and a small prism. We know the length of the large prism is 28 centimeters, which is provided as the measurement of the bottom edge. Similarly, we know the width of the large prism is 18 centimeters, as it is a provided measurement. We now have all three measurements we need to calculate the volume of the large rectangular prism. Length multiplied by width multiplied by height, or 28 centimeters multiplied by 18 centimeters multiplied by 11 centimeters. Using a calculator, we can determine the volume of the large prism to be 5,544 cubic centimeters. Next, we need to determine the volume of the smaller prism. We can determine its length because we know the longest edge of the original prism before we decomposed it was 40 centimeters. The measurement of the smaller prism's length is the difference between 40 centimeters and the length of the larger prism. 40 centimeters minus 28 centimeters is 12 centimeters. Similarly, the width of the smaller prism is the difference between the width of the larger prism and the given measurement of 7 centimeters, or 11 centimeters. We now have all three measurements needed to determine the volume of the smaller rectangular prism. Length multiplied by width multiplied by height, or 12 centimeters multiplied by 11 centimeters multiplied by 11 centimeters, which is equal to 1,452 cubic centimeters. By adding the volumes of each of the decomposed prisms together, we can discover the total volume of the original rectilinear prism. 5,544 cubic centimeters added to 1,452 cubic centimeters is 6,996 cubic centimeters. The volume of the original prism is 6,996 cubic centimeters. The objective for this lesson was to decompose rectilinear prisms to calculate volume. We met this objective by reviewing the formula for volume, decomposing prisms into smaller rectangular prisms, and calculating the volume of each smaller prism. We then added the volumes together to determine the total volume of the original rectilinear prism.